5. We have been given sec of an angle theta 13 over 12. We are supposed to calculate all other trigonometric ratio. So let's draw a quick right angle triangle ABC where B has the right angle and the hypotenuse will be always AC, the longest side, irrespective of whichever angle you are considering. As far as angle A is concerned, we are supposed to have this BC as opposite side, directly facing opposite to it, and the AB side will be adjacent. Now, there are 6 trigonometric ratios altogether. Let's quickly have a recap. Sine, cosine, and tangent. These are the original 3 trigonometric ratios. Now, on top of that, you have 3 reciprocal ratios. So, reciprocal means 1 divided by that particular trigonometric ratio. So, 1 divided by sine theta will be always cosec theta. You can see that other way around also. 1 over 1 divided by cosec theta is sine theta. So that's why I have shown this bidirectional arrow. 1 divided by trigonometric ratio on this side is equal to this one. Or you can say the other way around also. 1 divided by trigonometric ratio on this side is equal to this one. So 1 divided by sine theta is cosec theta. Similarly, 1 divided by cos theta equal to sec theta and vice versa. And 1 divided by tan theta is equal to cot theta. So out of that, let's say 1 is given. So sec theta is 13 over 12. That I will quickly write it down. We are supposed to find out the remaining 5. Well, cosine theta, I can do that without much calculation because we know that these two are related to by reciprocal relation. So 1 divided by this will be cosine. All I have to do is like simply flip this ratio. Instead of 13 by 12, it will be 12 by 13 because they are reciprocal. 1 divided by 13 over 12 is same as 12 divided by 13, and that will give me cosine theta very easily. Now, as far as the remaining 4 trigonometric ratios are concerned, we know that cosine theta is now 12 over 13, which is adjacent over hypotenuse. So if the adjacent is 12, I will write hypotenuse as 13 in the original triangle. Adjacent, let's say as far as angle A is concerned, adjacent is 12 that I will pick from here, and hypotenuse will be 13. So since this is a right angle triangle, I can consider this, I can use Pythagoras theorem here, and I can say that 12 square plus whatever that opposite square will be 13 square. So that will give me opposite as difference of squares when taken square root. 13 square, which is coming from hypotenuse, minus 12 square and under root. 13 square is 169, 12 square is 144. Their difference is 25, so the square root will be simply 5. I strongly recommend that you remember the squares of the first 30 natural numbers. And in addition to that, you remember some basic Pythagoras triplets also. In this case, 5, 12, and 13 are Pythagoras. It's a Pythagoras triplet. Those who know that will have very little difficulty in calculating this one. So now, let's say now we know all 3 sides. I can calculate now sine theta. Sine is opposite over hypotenuse. Opposite came out to be 5. Hypotenuse is 13. So now sine theta is 5 over 13. Once I get this information, I can easily switch to cosec theta, which is nothing but reciprocal. So cosec theta is simply the flipped version of this sine theta ratio. So 1 divided by 5 by 13, I will write as 13 over 5, simply by exchanging numerator with denominator. Now, as far as tan theta is concerned, tan theta can be calculated as opposite over adjacent. That's one way of doing it. But let's use the trigonometric identity. Tan is equal to sine divided by cos. Sine has been 5 over 13 and cosine is 12 over 13. This divided by 13 will cancel with this divided by 13. So your tan theta will come out to be 5 over 12. Let's write down that here. Once we know that 5 by 12 is tan theta, cot theta is not a very difficult task. Simply we have to flip numerator with denominator. Cot theta will come out to be 12 divided by 5.